Hello students, in this video we have 6th additional exercise problem of chapter 6. The question is, obtain an expression for the mutual inductance between long straight wire and a square loop of side A as shown in figure. Second question is, assume that the straight wire carries a current of 50 ampere and loop is moved to right with constant velocity v equal to 10 meter per second. Calculate the induced EMF in the loop at the instant when x equal to 0.2 meter. Take A is equal to 0.1 meter and assume that the loop has large resistance. The situation is given here. Now, the problem here is when we try to find out mutual inductance as required by A, first question, the formula is M is equal to phi by I. So, I will need flux linked with this square loop and I, that is current passing through this straight wire. So, as the current pass through this wire, if you apply right hand thumb rule, you realize that the field lines are going inside on the right side of wire and coming out from left side of the wire. To realize this, keep your right hand thumb along the direction of current and see the curling of wire, curling of your fingers around the wire. So fingers are going inside on the right side of the wire and you will see fingers are coming out on left side. So for this loop, the field lines are going inside through this loop. But the problem is, as you go away from the wire, if we label it as say P, Q, R, S, then the field experienced by PQ and the field experienced by SR both will not be same because the distances are different. If PQ is at X distance, QR will be at X plus A distance. And then according to the formula of magnetic field is mu 0 I by 2 pi y. Okay, magnetic field of straight wire. So how do we find out the magnetic field? And if we cannot find out magnetic field, then how do we find out flux? So as the B value is varying, we will have to go for integration. So what we can do is, we will take small part of the loop, consider that this is straight wire and then uh, this is the square loop, and what we know is that one side is at x distance, but we will consider a small part of the loop and then first we'll find out flux linked with this small part, we'll call it d phi and then we will integrate. So if this is P, Q, R, S, we consider at R distance a thin part of thickness dr. Okay, we know that this is A and this is also A. So how much is the area of this thin part? It is A multiplied by dr. Okay, so let us first find out flux linked with the thin strip d phi, that is B into A. What is B? Mu 0 I by 2 pi r. And what is area? Area is A dr. Now if I want total flux, I should integrate it. So integration d phi is integration mu 0 I A by 2 pi r dr, and as we are integrating from PQ, that is at x distance, to SR, which is at x plus a distance, the limit of integration should be from x to x plus a. So mu 0 constant, I, A both are constant, 2 pi is also constant. So we have 1 by r dr, and of course the limits x plus a and x. So integration of 1 by r is mu 0 I a by 2 pi, and integration is log of r. Substitute the limits and you will have phi is equal to mu 0 I a by 2 pi log of x plus a minus log of x. If it is subtraction, you can write it as mu 0 I a by 2 pi log of x plus a by x. So that is the flux required, mu 0 I a by 2 pi log of E x plus a by x. And then if we look at the formula of mutual inductance, if it is equation 1, from equation 1 and 2, we get m is equal to mu 0 a by 2 pi log of x plus a by x to the base e. So this is the mutual inductance of this system of square loop and a straight wire. That is answer of A. Second one, uh, assume that the straight wire is carrying some current 50 ampere and loop is moved, and find out the EMF, calculate the induced EMF. So induced EMF can be found out by taking epsilon is equal to BBL formula. What is B? Mu 0 I by 2 pi x. What is V? V is, I think, given. L is also available. Let me make list of data given. So I, current passing through the wire, is 50 ampere. X is 0.2 meter. Velocity with which loop is moved is 10 meter per second, and area or length, not area, length of the square is 0.1 meter. So all the values are available. So substitute all the values in this formula and carry out calculation. So that is all about this numerical, 6 numerical of additional exercise problem. Thank you.